theta, and del V equals to 54 volt. Nature. Dual nature of radiation and matter. That's what we are going to study now, okay? Wave nature of particle, wavefront theory. Thomas Young, interference of light, Young's double slit experiment, okay? Interference of light, Young's double slit experiment. Particle nature. Two particles have tendency to collide if come in contact at the same time. Wave nature, okay? First, Young's double slit. Young's double slit experiment. Hello, Supreme. Young's double slit experiment. Newton. Corpuscle theory. Huygens wavefront theory. Photoelectric effect. Einstein. Photo. Einstein. Particle nature. Light. Light has both particle and wave nature. Particle and wave nature. Particle and wave nature. Light has both. Okay. Photons. Packet of energy. Light travels in the form of photons. In the form of photon. 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 Photons has put momentum. P. Momentum. And what else? Okay, speed of light. Speed of light is the speed of photon energy, momentum, mass into velocity. Light carries both energy and momentum in the form of packets of energy called photon. According to quantum theory, light travels in form of energy packet. Okay, when photon share as energy, photon completely share करता completely share करता partial sharing मध्ये ना completely shares its energy. Photon ने अपना energy completely share करता partially share करते ना. When photon shares provide its energy, it shares all of them, complete sharing, transfer photon. Okay, small. I think I can do it this. Properties of photon. Properties of photon. 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 Properties of photon. Properties of photon. Photons travel with the speed of light. Travel with the speed of light. Speed of light. C equals to 3.8 into 10 to the power. It is 3.9 into 10 to the power. Hello. I know 3 into 10 to the power 8 meter per second. 2.99. I know. Mass of photon 0. Mass of photon at rest. Photon at rest is equals to 0. Then we have photon is not a particle. Photon is not a particle. Photons are not deflected by deflected by electric field or magnetic field. Rest mass of photon is 0. They are electrically neutral. Oh, how can I forget the important point? Photons are electrically neutral. They are electrically neutral. Since the photon is not a particle, it's just a form of energy, packet of energy, right? Rest mass of photon is 0, electrically neutral. Photons are not deflected. Photons are not deflected by electric field or magnetic field. In fact, magnetic fields and electric fields are made up of photons, right? These fields are made up of photons only, okay? Neutral, so can't be deflected. Photons are neutral, can't be deflected. Energy of photon. Energy of photon. 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 E equals to h nu or hc upon lambda. 12,400 upon lambda in Armstrong. Energy will come in electron volt. Or hc. E equals to hc upon lambda in nanometer, which is 12,040 upon lambda in nanometer. Lambda in nanometer, electron volt mein answer. Okay. Energy of photon is given by E equals to h nu or hc upon lambda. 12,400 lambda in Armstrong or 12,040. H equals to 6.6 into 10 to the power minus 34 kg meter square per second. 3 into 10 to the power 8 meter per second. This is speed of light. 1240, that is lambda in nanometer, okay? Mu is frequency, lambda is wavelength. Electron volt to joule. If we have to convert anything, energy, if energy is given in electron volt and we want to convert it in joule, then we have to multiply the given energy, which is in electron volt, with 1.6 into 10 to the power minus 19. The answer will come in joule. What if the energy is given in joule and we want it in electron volt? Energy is given in joule, then we want it in energy in electron volt. Then we have to divide energy in joule, given energy given in joule, upon 1.6 into 10 to the power minus 19. Energy will come in electron volt. Momentum of photon. Momentum of photon. P equals to E upon C, energy upon speed of light. It is also given P equals to H upon lambda. That is H nu upon C. These are the three different variations of momentum. P equals to H upon lambda, E upon C, or H nu upon C. C is speed of light, E is energy of photon. Formula of momentum: H nu upon C. Speed of photon is equal to speed of light. Photon is equal to speed of light. Do not depend on wavelength. Speed of photon do not depend on wavelength. Photon do not depend on wavelength. Speed of photon do not depend on wavelength. Light is made up of photon. Photons carry energy. Speed of wavelength and photon is same because light contains photon that stores energy. Okay. Speed of photon constant answer, do not change with change in wavelength. Speed of photon do not change with change in speed of photon do not change with the change in wavelength. Electromagnetic spectrum. Electromagnetic spectrum. Radio waves, microwaves. Radio waves, microwaves. Roman men invented infrared, visible. Then we have UV. X-rays. Roman men invaded Venus using X-ray. X-rays, gamma rays. So, here, energy is maximum. Gamma rays has maximum energy, maximum frequency, but minimum wavelength. Wavelength is minimum. here in radio waves, wavelength is maximum, energy is minimum, frequency is also minimum. Okay. When we go from radio waves to gamma rays, energy increases, frequency increases, wavelength decreases. Wavelength minimum, maximum energy, maximum frequency. Here, radio waves energy minimum, frequency minimum, but maximum wavelength. All the photons of this electromagnetic spectrum moves with same. Okay, all the photons in this electromagnetic spectrum moves with the same speed, that is speed of light, but they have different differ into different frequency, different value of frequency and energy. Gamma rays can ionize our blood. Okay, wavelength of gamma rays is 10 to the power minus 15. Okay, mm, equals to h nu equals to hc upon lambda. Frequency and wavelength is different. Frequency and wavelength is different for different spectrum, different radiation or spectrum, but speed is same for all. Okay, frequency is equals to oh, this is not frequency, this is velocity. Velocity is equals to frequency into wavelength. Okay, so from here frequency is equals to v upon lambda, which is c upon lambda, right? What if we have to calculate c from here? Speed of wave, right? Frequency into wavelength. Speed of photon is equals to frequency upon wavelength. Frequency from here, frequency c upon lambda. Yep. C upon lambda. Frequency c upon lambda. If hc, h nu upon c, right? If we wrote nu equals to c upon lambda, velocity of light upon lambda, then we can write it as h into c upon lambda. From here both the c's are gone, then momentum will be h upon lambda. I see. So I can do small calculation here. P equals to h nu upon c. Nu is equals to c upon lambda. P equals to hc upon c. A good. That is h upon lambda. We know that speed of light is equals to frequency into wavelength. Key point. Momentum B, energy E, speed of light C, wavelength lambda. Armstrong. 10 to the power minus 10 meter, nanometer. 10 to the power minus 9 meter, and if there is mega, 10 to the power 6. The energy of photon of wavelength lambda, E equals to hc upon lambda, hc upon lambda. If the wavelength of photon is lambda, if the wavelength of photon lambda equals to 3100 Armstrong, then energy of photon will be in electron volt. In electron volt, E equals to hc upon lambda, right? It is given in Armstrong, then 12,400 upon 3100. 0 0 cancel. 1 2 4. 31 plus 31. 2 1 2 3. 3 1 3. No, 4. 4 1 4. 1 4. 4 8. 4 3 12. 31 1 31. 31 4 1 2 4. So energy is equals to 4 electron volt. Correct? And if I want this in joule, then I have to multiply it with 4 electron volt into 1.6 into 10 to the power minus 19. Energy will be in joule. Okay. 4 5 is 20, 4 6 is 24, 4 2 is 4 4 5 6. Okay, 6.4 minus 19 joule. Correct. The wavelength of a photon, lambda equals to 120 nanometer. The energy of photon will be in electron volt. Electron volt, Hc upon lambda, that is 1240 upon 620 nanometer. 0 0 cancel. 62. Okay, this is 62 1 62 62 2 is okay, this is 2 electron volt. Correct. If I have to calculate this in joule, 2 electron volt into 1.6 into 10 to the power minus 19, that is 2 6 are 12, 2.2 1 are 2, 3, 3.2 into 10 to the power minus 19 joule. The wavelength of two photons, lambda 1 equals to 2000 Armstrong and lambda 2. Lambda 2 is equals to 4000 Armstrong. Then which of the photon has more energy? Which photon? Energy of photon is inversely proportional to wavelength. So whichever has the maximum wavelength, 4000, right? This one is 4000. Maximum wavelength will have minimum energy. So lambda 2 will have minimum energy. The wavelength of two photon. So this has less wavelength, right? More energy, correct? Minimum energy. If two photons having their wavelength 4000 Armstrong and 6000 Armstrong respectively, then speed of light will remain same. 4000 Armstrong and 6000 Armstrong respectively. Okay, their speed of light c remains same. Speed of photon is always same. Do not change with the change in wavelength, right? This first has max energy, more energy, MORE, more energy, 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 less energy. क्योंकि energy is inversely proportional to wavelength. I haven't written this. This is important. I haven't written. Energy is inversely proportional to wavelength. Thank you, Rishabh. If frequency is n equals to 10 to the power 16 hertz, then its energy will be energy E equals to h nu, that is 6.6 into 10 to the power minus 34 into 10 to the power 16. Energy equals to 6.6 into 10 to the power 16, that means 14 minus 6, 7 8 9 10 4 plus 4 8, 2 minus 1 1, 6.6 into 10 to the power minus 18 joule. H equals to 6.6 into 10 to the power minus 34 kg meter square per second. Energy, H nu, energy in joule, always as a unit used, okay. Whenever we use energy, whenever we use SI unit, then the energy will come in joule. Energy will come in joule whenever we use SI unit. Momentum of photon of wavelength lambda, P is equals to h upon lambda, that is h upon lambda. The other variations are E upon C or h nu upon C. Correct. Wavelength 2000 Armstrong, then find its momentum. P equals to h 6.6 into 10 to the power minus 34 upon 2000 Armstrong. 2000 Armstrong. I have bring this in meter, right? P equals to 6.6 into 10 to the power minus 34 upon 2 into 10 to the power minus 2 into 10 to the power 3 into 10 to the power minus 10 meter. So from here 6.6 upon 2, that is 3.3 into 10 to the power minus 34, and from here 10 to the power minus 7, when it goes up, plus 10 to the power 7 minus 7, right? When it goes up, plus 7. 3.3 into 10 to the power minus 7, 14 minus 7, 7, and here we have 2 minus 2, 27. 3.3 into 10 to the power minus 27 joule. kg meter square per second, I don't think so. The energy of a photon of light is 3 electron volt. The energy of photon of light is given, that is 3 electron volt. Then the wavelength of photon must be lambda. We have to calculate wavelength. Okay, E equals to hc upon lambda. It's given in nanometer. Okay, then we have to use 3 electron volt equals to 1240 upon lambda. Lambda equals to 1240 upon 3. 3 1s are 3, 3 4s are 12, 3 1s are 3. This is lambda equals to 4 1. Yep, 4 12. 3 4s are 12, 3 1s are 3, 3 3s are 9. Okay, it is given in nanometer. Okay, so the answer will come in nanometer. 413.33. Yep, 413.33, correct. The momentum of photon of energy 1 mega electron volt in kg meter per second. Okay, so this unit is correct. The momentum of photon of energy 1 mega electron volt. 1 mega electron volt, that means 1 into 10 to the power 6 electron volt. 1 mega electron volt. 1 into 10 to the power, that is 10 to the power 6 electron volt, obviously. Will be P. Energy is given, right? So we can directly divide it with 3 into 10 to the power 8. This will be like 1 upon 3 into 10 to the power 6 when it goes up minus 8. This will be like 1 upon 3 into 10 to the power 6, 7, 8 minus 2. 10 by 3 into 10 to the power minus 3. 3 1s are 3, 3 3s are 9. It is approximately 3.33 into 10 to the power minus 3 kg meter per second momentum. Kg meter per second, right? It is given in electron volt, that means we have to convert it in joule. Okay. One mega electron volt, we have to first convert it into electron volt, 10 to the power 6 electron volt. Again we have to convert it in joule. Then 1.6 into 10 to the power minus 19 into 10 to the power 6. This is in joule. So from here we can calculate momentum E upon C, that is 10 to the power 6 into 1.6 into 10 to the power minus 19 upon 3 into 10 to the power 8. 1.6 into 10 to the power 6, 19, 9, 66, 7, 8, 9, 13 minus 13 minus 8 upon 3, right? That is 1.6 upon 3 into 10 to the power minus 13 plus 8. 20, 18, 19, 20, 21 minus 21. That means 16 upon 3 into 10 to the power minus 22. 3 ones are 3, 3 fives are 15. 5.33. This will be approximately 5.33 into 10 to the power minus 22 kg meter per second. 5.33 into 10 to the power minus 22 kg meter per second, correct. If momentum of two photons are same, then energy momentum P equals to E upon C. This is constant. Speed of light constant. If momentum of two photon is same, if this is same, then energy will be same. Must be same. Speed of light always same. The energy of two photons are same, then their momentum. Again, if energy is same, this is constant, then their momentum must be same, correct. Photoelectric effect. When light of appropriate frequency is incident, appropriate frequency h nu is incident on a metallic surface, electrons are liberated from the surface. This phenomena is called photoelectric effect. Metal, photosensitive plate, source, quartz window. Photons are incident on this metal plate, that is photosensitive plate. Photons are incident on photosensitive metal plate. Evacuated gas tube, vacuum tube, evacuated gas tube, vacuum tube, circuit break. Another metal plate. This is vacuum. Commutator. What type? This is photocurrent. Ammeter. Source current flow, current deflect. Source current flow, current deflect. Ammeter, deflect. Potential difference equals to h nu. Frequency of photon increases, energy of photon increases. Directly proportional. 1 cycle per second, right? Particular, fixed. Threshold frequency of photon can release electron from metal. Different threshold frequency is needed for different material. Metal की property है. If you change metal, threshold frequency may change. Metal change हुआ तो frequency change. Threshold frequency, okay, do not depend on source of light. Different frequency is needed for different threshold frequency is required for different metal. Current flow, current ammeter, deflect. Ammeter, deflect. When current flows, high ohmkar. We have work function, right? Work function 5. Minimum energy required. Work function is the property of metal. It is the minimum energy required to release an electron from the metal surface or metal plate. It is the minimum energy required to remove an electron from metal. Energy required to remove an electron from metallic surface. Okay, it is a property of material. Work function do not change with a change in source. It is because it is the property of material, right? Metal. Do not depend on source of light. Okay. Work function do not depend on source of light. Work function. Work function do not depend on source of light. Work function change only when we change the metal plate, because it is the property of material or metal. Stop. If a photon of wavelength 4000 Armstrong is incident on a metal having work function phi equals to 2 electron volt. 2 electron volt. If wavelength of photon is reduced to 2000, okay, wavelength is reduced to 2000 Armstrong, then work function of this metal is, it remains same. I think it remains same. If a photon of wavelength 4000 Armstrong is incident on a metal having work function 2 electron volt, right? If wavelength of photon is, it doesn't change with wavelength, right? Because it is the property of metal. It can change only if we change the metal plate. If wavelength of photon is reduced to 2000 Armstrong, then work function of metal is, okay, energy equals to threshold energy. Work function. I think it will remain same. Yep, it will remain same. Minimum energy required to remove electron from metal is work function. जब तक metal change नहीं होगा, phi change नहीं होगा. Property of metal. Okay. If a distance of light source is doubled, new work function of metal will be. Now they are talking about intensity, right? It will remain same, because even if we change the source, phi won't change. It is the property of metal. Property of metal, it does not matter with the source distance, will remain same. Work function. Okay, where can I write it? Phi. Work function. It do not depend on source of light. Source of light or its distance. GST light or its distance. I got it. I am here till 8 am and then bath. You mean you will stay here till 8 am, right? And then you will go for bath? But this live session will end soon. At 6 o'clock, someone will come. I have to teach her. There is a student of mine. She studies in class 10th. So I have to teach her. At 6, I'll end this session. Phi. Work function. Do not depend on source of light or its distance. It is the minimum energy required to remove an electron from metal. Do not depend on source of light or its distance, right? Okay, even if we change the wavelength, it doesn't affect work function. Do not depend or change with the change in wavelength. You're acting like a girl. You said OMG. Yup, OMG. Till then, let's study. It's less than half an hour. Good luck, Omkar. Threshold frequency. Wavelength. It is the minimum frequency or maximum wavelength at which emission of electron starts or photoelectric effect emission is absorbed. Threshold frequency or cutoff wavelength. Threshold frequency, which is somehow related to work function. Wavelength is cutoff wavelength. Threshold frequency or cutoff wavelength. It is the minimum frequency or maximum wavelength. It is minimum frequency or maximum wavelength at which emission of electron starts or photoelectric effect emission is absorbed. Threshold frequency is the minimum amount of energy, minimum frequency that is needed to remove an electron from the metal surface. Or maximum wavelength. Cutoff wavelength is the maximum wavelength. Threshold frequency. Minimum frequency, cutoff wavelength, maximum wavelength. It is the minimum frequency. Threshold frequency or cutoff wavelength. It is the minimum frequency or maximum wavelength at which emission of electron starts or photoelectric emission. Photoelectric emission or effect is absorbed. Energy of photon at threshold frequency or threshold wavelength will be equal to work function. Energy of photon at threshold frequency or cutoff wavelength, it will be equal to work function. That means E equals to work function. Energy of photon will be equal to energy of photon will be equal to work function. Energy of photon will be equal to work function. Energy of photon is written as h nu naught, right? This is threshold frequency. Nu naught is threshold frequency. Threshold frequency. Okay. Work function or hc upon lambda cutoff equals to phi. hc upon lambda naught equals to phi. Threshold frequency, cutoff wavelength. Maximum wavelength, minimum frequency for photoelectric emission. Energy of photon at threshold frequency or cutoff wavelength will be equal to work function, because work function has the same definition, right? Minimum energy required to remove an electron from the metal surface. H nu naught equals to phi. Let's say upon lambda naught equals to phi. Threshold cutoff wavelength. Minimum energy of photon to emit electron. Threshold frequency. In terms of threshold frequency, h nu naught equals to phi, which is correct. In terms of cutoff wavelength, let's say upon cutoff wavelength equals to work function. Correct. Threshold frequency, kg meter per second, SI unit of momentum, right? Energy should be in joule. Meter per second, speed of light. That's it. In joules. Work function of metal is phi. 3.1 electron volt. Work function of metal is phi equals to 3.1 electron volt. Threshold frequency, then threshold wavelength will be cutoff wavelength, lambda cutoff Armstrong. Then this will be, we have the formula hc upon lambda is equals to phi, which came from E equals to phi, right? hc upon lambda. We have to calculate lambda. Okay, then it will be lambda equals to hc upon phi, which will be equals to 12,400 upon 31, 3.1 electron volt, right? 3.1 electron volt. This will come in, I think this will be in Armstrong. 124 upon 3.1. Okay, 31. Okay, 31 ones are 31, 31 threes are. Okay, 3. No, 4. It's 4 ones are 4, 1s are 4, 4 is 4, 12. 4,000 Armstrong, correct? 4,000 Armstrong, correct. Threshold. Threshold wavelength of metal is threshold wavelength of metal is 12,000 Armstrong. The work function will be, that is hc upon lambda. We have to find phi, that is phi equals to, okay, it is given in Armstrong. Lambda is given in Armstrong. We are not aware of this value, right? If it is given in Armstrong, that means it is 12,400. 1200. 12 ones are 12, 12 ones are 12. 2 6 are 12, okay? 2 6 are 12, 2 2s are 4. 2 3s are 6. 2 3s are 6, 2 ones are 2. 3 ones are 3, 3 tens are 30.33333. Phi equals to 30.33 electron volt. Hmm. 10.333 electron volt. It's given in Armstrong now, so we have to put the same value. The photoelectric work function for a metal surface is 4.125 electron volt. The photoelectric work function for a metal surface is work function phi equals to 4.125 electron volt. The cutoff wavelength for this surface is, okay, lambda. Wavelength in Armstrong, okay, in Armstrong. Then we have the formula E equals to phi. Energy of photon. Energy of photon at threshold frequency, okay. Energy of photon at threshold frequency, hc upon lambda equals to phi. From here we can write that hc upon phi. Lambda equals to hc 12,400 upon 4.125 electron volt. 12400 4125 into 10 to the power minus 3. 5 ones are 5, 5 twos are 10, 5 fours are 20, 5 eights are 40. 5 eights are 40, then here 5 twos are 10, 5 fives are 25. Then we have 2480 upon 825 into 10 to the power minus 3. 5 ones are 5, 5 ones are 5, 5 are 25, 5 6 are 30, 5 fives are 25, 5 fours are 20, 5 nines are 45, 5 6 are 48, okay. 5 is 25, 5 6 are 30, 5 6 are 30, right? 5 6 are 30, This will be like 496 upon 165. 3 5s are 15, 3 5s, okay, this is divisible with 3. What about this? 3 1s are 3? No, this is not divisible. Then let's do it. 165 into 3 is 5 1s are 5 is 10, 5 3s are 15. Then 4 5s are 20. Oops, no. 5 5 is 10, 5 3 15, 5, 1 is the way. 6 6 12, 6 8 10, 19. 1 is the way. 3 1s are 3 4. 4 9 5. Almost 1s are, and this is 3.1. 3.0 something. This is approximately 3.0 electron. This is not an electron volt. Upon 10 to the power minus 3, right? Then lambda is equals to 3000 Armstrong. This is approximately 3000 Armstrong. Where is the question? Here it is. Approximately 3000 Armstrong. Correct. If the threshold frequency for a certain metal is 2000 Armstrong, then find the work function of metal. Threshold wavelength. Lambda naught is equals to 2000 Armstrong. Then find the work function of metal, phi. Phi equals to hc upon lambda. Everything is given. The threshold frequency of wavelength of a certain metal is then the find the work function of the metal. Then this will be like 12,400. Four 4.2 electron volt. 4.6 electron volt. What the heck? 2 4s are 12. Let me check again. 2 1s are 2, 10. 2 4s are 12. 2 2s are 4. Then how come there is... Why I do the same mistake again and again? It's 2 3s are 2 1s are 2 2s 4 2 3s are 6. Then this is 2 6s are 12, not 2 4s are 12. I do the same mistake again and again. This is not 42, this is 62. 2 3s are 6, 2 1s are 2. This is 3.1 electron volt. That means phi equals to hc upon lambda. 12400 upon 2000 Armstrong. 2 10s are 20, 2 6 are 12, 2 2s are 4, 2 5s are 10, 2 3s are 6, 2 1s are 2, 5 1s are 5, 5 2s are 10, 5 3 are 10, 5 was 20, 5 was 25, 5 6 are 30, 5 2s are 10. Phi equals to 6.2 electron volt. Hi Surya. Frequency new knot is given. Hertz SI unit. Function will be kg meter square per second, right? Hmm. Tight. This comes in joule. If we have to convert this in electron volt, then we have to divide it with the 1.6 into minus 19. When this goes up, this will get cancelled out. 66 upon 16. 2 3 is a 6, 2 3 is a 6, 2 8 is a 16. 8 upon 33. It was a 32. I swear it was a 32. 8 ones are 8. Then again 2. It was 16. This will be like 4.12 electron volt. 2 3 is a 6, 2 3 is a 6, 2 8 is a 16. 33 divided by 8. 8 1 is 8, 8 was 16, 8 written for 8 4 is a 32. That is 1 0 point 0. 8 1 is 8, 8 2 is a 6. Okay, this is 4.1. 8 10 minus 8 again 2. 8 1 is 8, 8 2 is a 16. 4.12 electron volt. 3.112. Musu tera utiko.
Ada rani pun जा ada surrender राजा.
Ja. .6 divided by 1.9. 1.9 or 1.6? 4.125. Correct. The work function for a metal A, B and C are respectively A, B and C work function. This is phi is equals to 1.92 electron volt, 2.0 electron volt and 5 electron volt. A, B and C. The work function for metal A, B and C are respectively 1.9. Okay. According to Einstein equation, metal which will emit photoelectrons for a radiation of wavelength lambda equals to how much? 4100 Armstrong. Okay, let's check. Phi is equals to hc upon lambda. That means 12,400 upon, is it 4100? It is, okay, 41. Okay, 4 ones are 4, 4 fours are 16. That means 2, 2 ones are 2, A. 41 upon 3, 3 ones are 3, 3 is 9, 3 fours are 12, 1, 2, 3. That means this is 41 ones are 41, 41 threes are 123 point, there is 1, right? 1. Hmm. 1 पॉइंट लगा के एक 0 10 ही आएगा. हाउ मच इज दैट? 3 3 पॉइंट, फिर से एक 0 करने के बाद 100. 41 1 41, 41 2 82. Is it? Yeah, it is. 2 3.02. Phi equals to 3.02 electron volt. That means the metal which will emit photoelectrons for a radiation of wavelength this will be less than 3.0 electron volt. A can obviously emit photoelectron for this radiation. Okay, B, yes, B can, but C can't. 5 electron volt minimum energy required for third metal is 5 electron volt, and we just got 3.02 electron volt. Okay, so only A and B correct. When ultraviolet rays are incident on metal plate, the photoelectric effects does not occur then it occurs by the incidence of those radiation which has more energy, X-rays or gamma rays. The answer is X-rays. More energy is required, na? During a certain minimum energy of frequency. Just one frequency. If plate with threshold frequency more than if we make a light incident on metal plate with threshold frequency more than threshold frequency THN, then threshold frequency, the electron may or may not eject. मिनिमम थ्रेसोल्ड फ्रिक्वेन्सी भन्दा मिनिममको लाइट इन्सिडेन्ट जति नै लामो बेरसम्म गर्दाखेरि पनि के हुन्छ, फोटोन निक्लिँदैन. There exists a certain minimum frequency energy of incident. The minimum frequency energy is called threshold frequency or threshold energy. Threshold frequency, yeah, or threshold energy. If an incident frequency greater than the threshold frequency is incident on a metal plate. Just calm down. Electron may eject. One photon can eject maximum of one electron, no matter how high its energy. Instant photoelectric equation. Equation.